This is a DIY tabletop newsstand. It sits quietly on my table and passively displays the most recent news across the world on a tiny 2.9-inch e-paper screen. It updates every 3 minutes, but because I own the server that sends this news, I'm able to refresh anytime I want, as well as choosing what news topics I want to see. So in this video, I'm going to break down on how I implement all these things. Now, in terms of software, the e-paper screen that I bought came from a company called Waveshare. They also have this GitHub repository that provides sample code to render onto their e-paper screen. So there are things like Arduino, Raspberry Pi, Jetson Nano, and STM32, which corresponds to whichever circuit board that you have. In my case, I own a Raspberry Pi 3, so I'll be using this one. Now it comes down to the programming languages of your choices. There is C and Python, and I believe for most people, Python would be more friendly and easier to use. However, in my case, I prefer Python, but it just did not work. Nothing shown on the screen, and I've noticed a lot of people on their GitHub issues have had similar problems, and mostly without a solution. So anyway, let's run the C code. So in the C code, you want to go into examples, main.c, comment out what they had originally, which is likely to be the wrong size, and then uncomment the e-paper screen that you have. So in my case, it was a 2" 9 V2 version 2. So most of the e-paper screens from Waveshare are version 2 now. Uncomment that, and then go back. So this main.c will be calling 2" 9. It will be here. It will run through this code after you hit make. It will show a couple of demo images, including partial refreshes. And now, after you've done that, uncomment out the code there, you go back to this directory, hit the command make, and it should produce an EPD executable file. Now, here is my test file. I've simply just removed the example code and added my own. So what I wanted to do is for a newspaper to be displayed on the e-paper screen, I want to show what the time relative to now is, say 5 minutes, 1 hour, or 2 days, what the title of the news is, and what the publisher of the newspaper is, say ABC News or SBS, things like that. Fortunately, all of these ones I could get from my API of my news web server that I wrote. So what I had to do is delay a few seconds, render the image, and then put the texts respectively. You could experiment around with these to see which arrangement that you prefer. I came across where there are some Unicodes that did not render, so things like Chinese news or even double quotes or things like that. And their solution was to use drawstring CN, but it did not work for me either. So I've just commented it out for now and going to revisit it sometime in the future. Anyhow, it works with all the English news for now. And this is my function here. And back to main.c, what I would do is I wanted to fetch the API from the backend server and pass it to C. I could use the binding of C from Python. However, it doesn't seem to work with all the header files and other libraries. So I just thought I could just use the command line, just pass it from the command line. So I will be getting the command line from here, arguments, and pass it to the function write to screen with 3 arguments, corresponds to time relative, title, and publisher. So this is my Python file. In my Python file, I basically just say, okay, this is my write to screen command. I'm going to be passing in all the command line arguments here. I wouldn't recommend this in a real production system if you cannot trust all your arguments. But since my part is a toy project and I know what these things are gonna be, and I think that it's unlikely someone was gonna get into my backend server and change these, so I'm happy to just pass in the command line here. So now it will be running an infinite loop of getting all the requests. This is my backend server, this is the API, you could use it as well. Basically calls API async reads, get the feed, nodes, I don't need anything, but I need languages. So if you are interested, I could post a special video about the APIs that you can use. I've done things like you could filter what news you want by different keywords, by different languages, and also by and, or, not, the Boolean keywords, which is pretty advanced, and also what news source you want it to come from. Anyway, this just fetches all English news. And the response is a array that's in JSON with the time sorted from the most recent to the least recent. And basically it just gets the first news, the time relative to it, the title, the publisher, and writes it to screen, and it sleeps for 3 minutes and does it all again. So now what we want to do is to call this Python script using no hub and an ampersand at the back. This essentially puts the Python script running even after we disconnect SSH. So hit enter and there we go. Now you've also got ping outs in here, which you can refer to any Raspberry Pi GPIO headers, and also from the Waveshare you're able to see which of the pings going to which one. Here's a demonstration. Okay, now we are going to set up our hardware to connect our e-paper screen from Waveshare to our Raspberry Pi 3 or any other Raspberry Pi if you wish. First off, notice how there's a Rainbow cable. We're going to plug that in. And notice how there are different labels here. They correspond to the interfaces from our previous Waveshare wiki page. Plug this in, see which cable corresponds to which GPIO pin on the Raspberry Pi, and plug them in. And just be careful, don't mix up the numbers, and we're done. So now, in terms of hardware design, I've used Fusion 360 because it was relatively simple to learn. I've split the Raspberry Pi holder and the e-paper holder into 2 different components, as you can see here. Before all that, I have added parameters. Because it's parametric design, it's easier to add the parameters beforehand rather than going back all the way to change the sketch later. The pluses that you see here are the tolerances I've added after I've taken the measurements of the caliper just to get the right fit. In terms of all the measurements, trial and error as well, the tolerances spent around 4 to 5 iterations of actual printing just to get the right fit. Now you might have noticed that I decided to combine both of these 2 components together. Reason for that was I wanted to make something that's able to stand on the desk, and to minimize the printing time for each iteration, I decided the best way was to not add any extra stuff, but rather to have themselves stick together and able to stand. That would be the best solution. What I found was that the rainbow cable sticking out of this Raspberry Pi was able to make a lake of itself. So I thought, okay, I'm gonna print this like 2 of them like this way. So the rainbow cable was sticking out like around 45 degrees, and this whole thing was able to stand on its own. And now, this is it. This is the 3D printed model that you just saw. And here comes assembly. We just put this one in, and this one this way. This one in here. And as I said, rainbow cable itself is able to provide a lake as its own. And there it is, stands on the table. Pretty cool, huh?